Hello, and welcome to the TechHub.training Python Investing with Python Challenge Solution. This video solution includes using NumPy, Pandas, and Matplotlib. With that, let's get started. You can see here that I used Jupyter Notebooks to perform this solution. It doesn't matter which IDE you chose to use, but this is what I'll be using for this video. I broke up the code to make it a little more manageable for this video, but it would all work the same if you ran it in one cell. So this first cell simply imports our different libraries and packages, reads in the CSV. Mine is from a shared link, but it works the same if you stored the file locally on your computer. And then I converted the date to a datetime object, sorted the data frame, removed any duplicate rows, and then printed out the first few rows of the data frame. This was helpful to double check that the process worked throughout each coding step. For example, here we see that stock ticker A, the first date in this data set, was February 8th of 2013. And that's step one. Next code block, we first created a list of tickers to iterate through. And this was my approach to creating this summarized data. There are many different ways to do this, and I'm sure there are several more efficient ways to do this, but this is my approach. I created a list of tickers and used this for loop to find every unique ticker in the data set. Basically, it says that for every ticker in the stock data frame, if the ticker is not in this list of tickers, then add it to that list of tickers. That means that once it encounters a ticker for a second time, it won't add it multiple times. So each ticker in this list, once this loop is done, should be unique. And then I created some dictionaries, empty dictionaries, to store the starting and ending prices for each ticker. And then ran list loop, which took quite a while to run. But basically, for every ticker in this ticker's list, we found the first date for the ticker, the first date that it was in the data set, the last date for that ticker, and then using these dates, we found the starting price and the ending price, which is the opening price on the first day and the closing price on the last day. And then this part just appends to the dictionaries. And then down here, we use those dictionaries to create different data frames. And then this portion right here merges those data frames into one called summary data. And then down here, we print out the summary data frame, which shows the ticker name, the starting price, and the ending price. And again, we can compare this starting price, $45.07 for stock A, right here with stock A, $45.07. So that was the value in sorting this data frame earlier. So that's part two. Part three here is to create the dollar return and the percent return columns. And then as part of that, we needed to drop any that included divide by zero errors. So first, to create the summary data dollar return column, we just took the ending price minus the starting price and created that column. And then for the percent return, we took the recently created dollar return column and divided it by the starting price for each ticker. Then right here, we replaced any divide by zero errors with not a number, which is a data value available in NumPy. And then we dropped any of those from the data set and then printed out the first few rows. So we can see again that this all matches for stock A, for all of these stocks. We have a dollar return and the percent return. Please note that the way this is formatted, this isn't saying that this stock returned 0.5%. Rather, this should be 51%. I didn't reformat the percentage return here because it affected the histogram later. For the next part of the challenge, we simply needed to print the stock and the percentage return of that stock with the highest return. So I found the max return by simply using the max function on the percentage return column, and then used the loc method and that percentage return column. So if the percentage return equals the max return, it was supposed to bring the associated name from that row of data and set it equal to this variable. And then I used an F string here to print that the stock with the highest percentage return is NVIDIA with a return of almost 1750%, which is incredible. For the next portion of the challenge, I gave the S&P return and asked how many stocks outperformed the S&P 500 and what percentage of stocks that was. So I set this S&P return variable to that value, which corresponds with 78.56%, but it's in the same format as this column here, so that we're comparing apples to apples. And again, my code probably isn't as efficient as many of yours, but my method still works. I created a data frame with the high performers, basically that took the summary data and found where the percent returned column was greater than the S&P return, and it added those values to a high performers data frame. And then I sorted the data frame to show the highest performers at the top. I printed this out with an F string, changed the formatting, and used this to print out the number of stock, or the percentage of stocks in the data set that outperformed the S&P 500. And you can see down here that 44.53% of stocks in the data set outperformed the S&P 500, which is pretty impressive, but still not over 50%. The next part was to create a histogram based on the percentage return and include titles and labels. The way to do this is to use the pyplot that we imported as PLT. So plt.hist, and used our percentage return as the axis. I multiplied it by 100 here to show the actual interpretation of the numbers a little better. And then I used bins equals 200 to show the histogram a little better. I'll show you what it looks like without it actually. So, and then this adds the title, the label for the x-axis, and the label for the y-axis. So without the bins, this is what we get, and it's pretty unimpressive and not very informative. It's like, okay, well, there are a lot of stocks that look like they did worse than the S&P 500, but this makes it look like way more than half performed worse, where we know that it's actually pretty close to 45%. So by adding back our bins and running that again, it splits up the data a lot more, and so we can see that there are some stocks with negative returns, but the most often occurrence is right at that S&P 500 return. And you can see the shape of the distribution a lot better, that the bulk of stocks finished pretty close to the S&P 500, but then there are definitely some that outperform, and then there's NVIDIA, who just went all out during those 5 years. I didn't point out this line, plot AXV line, it's axis vertical line. And again, we use the S&P 500 return times 100 because that's what we want to standardize the values. I use the color black. You can change the color to red, blue, whatever you want. There are different line styles and different widths. If we set the width too wide here, it just kind of cuts out some of the data, so I like how we have it at 0.5. Anyway, that's the challenge solution. Thank you for visiting TechHub.training.